Today we're going to be making a simple subtractive synthesizer. So to start off with, we're going to make our voltage controlled oscillator, or a VCO, and this can be either a sawtooth, a square wave, which in Max is called the rect object for a rectangle, a triangle wave. There's a couple of triangles. We're going to use the anti-aliased tri tilde object, or we can also use a cycle object, which is just our garden variety sine wave. So that is our VCO, that is the oscillator that's going to be generating the sound. Secondly, we're going to need to feed the oscillator into a VCF, or voltage controlled filter. And for this, I'm going to use either the SVF or the low res objects. And lastly, we're going to need to feed these into a VCA, which is going to control the volume. And a VCA in Max is just a volume control. So just like every volume control in Max is just a times tilde object. But in order to control the VCA, we're going to need to make a envelope to generate the signal to control, say, what the volume of the synthesizer should be at any point in time. So to do that, we're going to use a line tilde object, and then we're going to send the message, the envelope as a message to the line tilde object. And then finally, we're going to have the output of our synthesizer, just like we had for the theremin. Okay, so here are our basic objects. I can make the subtractive synthesizer just by connecting my oscillator, going into my filter, and the output of my filter going into my VCA, and then the output of my VCA going to the output of my synthesizer. And at this point, what I need to do is create control objects so I can set the settings for each of these different elements. So for the sawtooth wave, I need to send it the frequency. If I hover over the inlet, you can see what it's expecting as a float or a signal. So this is the frequency, and this is going to be in hertz. For their filter, we also have a cutoff frequency, which is similar to the frequency for the oscillator, but it's going to control the cutoff frequency of our filter. And that will also be in hertz. For our envelope, we need to decide what kind of envelope we want to create. And there's several different types. We're going to use an attack release envelope right now. So an attack release envelope gets triggered once, has an attack time where the volume increases, a decay time where the volume decreases, and then the envelope ends after that point. So what we can say is we're going to go to the maximum volume in some amount of time, and then to the minimum volume in some other amount of time. And that is the actual control message we'll send. And then we need to make send those values to that message. Now, in order to do this, I'm going to use a pack object. What a pack object does is it takes two values and makes a list out of them. So I'm going to give it the default of 5 milliseconds for the attack time, 100 milliseconds for the decay time, and I'm going to connect it here. And then I'm going to create a bang object, and every time I hit this bang object, the contents of pack will get sent out. So let's try that. Whoops, there you go. So there we go. Every time this receives a bang, whatever is stored in these inlets is going to get sent to the message box and then create the envelope here. So we can change the values in the message box just by sending new values in with number boxes. Notice I'm using ints for this because attack and release times in milliseconds rather than a smaller value. Okay, so now that we've done that, we might also want to change the resonance of our filter. So that's going to be a float. Notice it tells you very nicely, it says it's going to be a value from 0 to 1. So send that in, and that is our resonance. We might even give ourselves that little note, and it wants to be from 0 to 1. And the next thing I want to do is make a bang object, and all the bang object is going to do is tell that envelope to go up and down. So if I change these to be sort of suitable parameters, right now we already have those set because the pack object has default values in it, but we'll also maybe just make it be a little bit longer so we can really hear it. And now I'm going to turn audio on, And when I push this bang, we can hear some sound. Now it's important to note that the VCO is making sound all the time. So we can see that the VCO is generating sound. We're actually not seeing a very accurate representation of the waveform here. Let's go ahead and make that a little bit better here. So there is our sawtooth wave. And it's just generating sound all the time, right? Similarly, when the VCO goes through the VCF, it's still just making sound all the time. Notice how the waveform shapes because the filter is changing the harmonics present within the waveform and changes the shape of the waveform. But we're still hearing it all the time. The envelope is the thing that controls the volume. If I change my filter frequency, you can see the envelope turn more into a sawtooth wave again. And you can hear the sound it has. Similarly, if I go down to like 100 hertz, we'll see it approaching a sine wave. Okay, so that is a very simple subtractive synthesizer, and from there we can build on this to create more complex synthesizers in the future.